So this is chapter 6, section 1, law of signs. It's actually broken up into 2 days. So we're going to do section 1 again tomorrow. We're going to study tomorrow something called the ambiguous case, which was possibly mentioned in Algebra 2, but I don't think that you did a lot with it. So that's going to be the one that's like brand new. Probably most of your like new knowledge is coming from section 1, day 2. Today it should be pretty low key, and you're kind of doing the things that you've done before if you've seen the law of signs. If you haven't seen the law of signs, I think you're going to be just fine. So what I would do is write down the law of signs in your notebook. You are going to be responsible for these formulas for the tests and quizzes. So I expect you to know the law of signs. Okay. The law of signs can go with any triangle ABC. It doesn't matter how you draw your triangle or how you label your triangle, other than side A is opposite angle A. That must always be true. Side B is opposite angle B, and side C is opposite angle C. Okay, so that would be really important. And then I will copy down your law of signs that you uncovered on the blue sheet. Again, if you have those flip-flopped, if you have A over sine A equals B over sine B equals C over sine C, that's fine. Okay. And then we're going to do an example where we use the law of signs. So I'm going to start with a picture. Again, it does not matter how you draw your triangle. Only thing that would matter is opposite side of an angle has the same letter, lowercase. And then when you label your picture, label the same letters. So wherever your angle B is, label it 118. Okay, so what you're going to be asked to do in section 6.1 and 6.2, and on your quiz next Wednesday, is solve the triangle. And solve the triangle, when they don't give you like a specific thing to solve for, it means find everything. So find all three angles and all three sides. Some things will be given to you, like I already know 2 angles and 1 side. We have to solve for those other missing things. What do you want to solve for first? Angle A, side A, or side B? Angle A, because that's really easy, right? How will you find angle A? All the angles add up to 180 in a triangle, so subtract 118, subtract 36. What is the measure of angle A? 26 degrees. Cool. Okay. Now, do you want to find side B or side... side B or side A? Side B. Okay, I heard someone say B. Okay, here's what I will do. And note that these are eventually going to be mixed up with other triangles, so you'll have to decide, should I use the law of sines for this, or should I use the law of cosines for this? Okay. If I can ever find a pair of a corresponding angle and its side, and I know both measures, then I can use the law of sines. So I know the pair of C's, right? I know angle C and I know side C. So I can create a ratio filled with numbers. The sine of 36 over 14. There's no variables in that ratio. That means I should be able to use the law of sines. On the other side, Abby said let's solve for side B, so that would be in my denominator. In the numerator, I need the sine of angle B, which is 118. What method would you guys talk about for solving that equation? Cross multiply, most people will say. So I'm going to write an extra step that I don't always write. B times the sine of 36 is equal to 14 times the sine of 118. And then in order for me to solve for B, I'm going to divide by sine 36 on both sides. Now, I will make one quick statement here about your calculator. Most calculators will bring up an open parenthesis for sine of 118, so just make sure that you close that parenthesis before you divide. And I would not round it. I wouldn't like evaluate these as decimals and then round. I'll just plug it into my calculator all in one step. So please do that. And what else should you be careful of with your calculator? Mode should be a degree mode. Okay, somebody give me that decimal, round to the nearest hundredth. What do you get? 21.03. Raise your hand if you're not getting 21.03 for B. We'll check your calculator and see if there's a mistake in your typing. And that's side B, so I'm going to label that over there. Now, we still have to find side, what, A? How can I find side A? Same thing, law of sines. Why would I not use Pythagorean theorem? Not a right triangle, right? So in chapter 6, we're moving out of chapter 4 where everything was right triangle trig, and now we're just doing like trig for all triangles. Okay. So one thing I always do for like when I solve my next side is I always go back to this original ratio, my two sides corresponding angle and side that I know. So I'm going to use sine 36 over 14 as opposed to sine 118 over 21.03 because that's been rounded. Okay, so I'm going to go back to the original so I can avoid rounding. So I'll say the sine of 36 over 14 is equal to the sine of 26 over A and then I can solve for A, cross multiply. I'm going to do 14 times sine of 26 and then divide by sine of 36. Now, this is a version I did a little bit less work than I did on the other one. If you feel comfortable with like your cross multiply, you can kind of write it out. I would still recommend show me what you're going to type into your calculator in case you get those two signs mixed up. But don't skip this step over here where you divide if you're going to not be getting these in the right order. Somebody give me a side length for A? 10.44. Any questions about how I solved the triangle there? So if you can fill in all angles and all sides, then you have everything solved for. You don't have to label the triangle. I just do that so I can see I found everything. On a side note, a way that you can check that everything seems to be working out okay. I can't remember if they call it triangle proportionality theorem in geometry. It's got a name, something with proportions. But it's the one that says your shortest side is opposite your smallest angle, and then the medium side is opposite the medium angle, longest side opposite largest angle. So just verify. My shortest side is 10.44. My smallest angle is 26. Shortest side is 14. Or sorry, medium side is 14, medium angle is 36. Longest side, 21, largest angle, 118. So it seems to have worked out. That's going to be an issue in chapter 6, where like in the ambiguous case, if you don't follow it correctly, you'll get something that doesn't make sense. Okay, one more thing that we're going to look at is the area of a triangle. And again, I'm just like copy and pasting the same triangle over and over, so it doesn't matter what your triangle looks like in any kind of way. Key here would be it's not a right triangle. Okay. So you already know how to find the area of a triangle. There's one formula you know really well. What is that formula? Base times height divided by 2, or 1/2 times base times height, whatever that may be. And that formula is valid, and that formula is really where this formula is going to come from. Okay, the formula that I'm going to give you today. So we're going to look at the area of a triangle given side angle side. And what I mean when I say side side angle side is when I look at my triangle, I won't know everything about my triangle, but I will have two sides and their included angle. So that's the angle that the two sides form. So an example of side angle side in this triangle would be, let's say I knew side C and I knew side B. So that's my side, and then the angle I would know would be angle A. Now, if we were using our old formula that Abby gave us, base times height divided by 2, I would need the base and the height of my triangle. Height is always perpendicular. It's like the altitude. So similar to what happened on that blue sheet, I could draw the height right there. And that would mean that's my height, and then B is my base. Okay. We're going to kind of set it up just real similar to what you did on the blue sheet. I'm going to use angle A, and I'm going to say that the sine of A is equal to H over C in this little right triangle right here. The sine of A is equal to opposite over hypotenuse. So sine A equals H over C. I wouldn't be able to do a tangent because B is longer than that right triangle. Okay, so I've got to use the hypotenuse and the opposite side. And then solve for the height. What is the height? C times sine A. And if I didn't know the height of the triangle, because remember that wasn't originally filled in, I could now plug into this formula that Abby gave me. Where you're dividing by 2, I'm going to use a 1/2, okay? So I'm going to say the area of the triangle, this A means area, equals 1/2 times base, which is B, normally times height, but height we've solved for in a right triangle is C times sine A. So remember, if all I knew, what I had originally highlighted here in green, was side C, side B, and angle A, side, angle, side, I multiply the two sides together, multiply by 1/2, multiply by the sine of the included angle, and that's going to be my area of a triangle. So I don't really need this height. The height is going to be C times sine A. Okay. Now, that's going to change if you're looking from a different angle. Okay? So if I were looking from angle C, my formula would be 1/2 times A times B times sine C. Okay, so you could repeat that process to find that formula. I'm not going to do that again. Okay, but that would be another version. If you looked at the right triangle formed by A, C, and the height, you could redo that work for the sine. And then look for a pattern here. If I knew angle B and the two sides C and A, what would be my next formula? A times C, those are the only pair we haven't used yet, and it'll be sine B. Okay. So this is only allowed when you have two sides and the included angle, side, angle, side. Okay, that's when that works. You know, when I'm doing this, I probably know one formula. I know the top one. 1/2 B times C times sine A. And then I just use that as like the two sides times the sine of the angle. Okay, whether it's A, B, C, or whatever. Let's look at an example. Find the area of this triangle. Now, on some of these problems, you're either going to get a picture or you're going to get something like this, where it just tells you angles and sides. Anytime I'm doing this problem where it just tells me angles and sides, I'm going to draw a quick triangle. For me, personally, I've got to see that triangle. Now, I don't care what that triangle really looks like. I don't worry about if I have correct side lengths or whatever. I'm just going to label 65 degrees, side B is 15, side C is 22. And what I can tell when I look at the picture is, what do I know about the triangle? Side, angle, side. So I can use the formula I just got. The formula I just got tells me the area of the triangle is 1/2 times the length of the two sides times the sine of the included angle. It's really not too bad at all. It will always be true if it's side, angle, side. Plug that in your calculator. Somebody give me a answer to nearest hundredth. 149.54. Type that in, make sure you can get that. And if this had units, I would label it in the specific units. Because it doesn't, I'll just call it units squared. So you should label your area as a square unit. Okay, done. So your homework tonight, if you check your goal sheet, you've got 8 problems. Some of them are going to be solving the triangle, so make sure you find all the missing angles, all the missing sides, and then some of them are going to be area problems. And remember, as you're doing your homework, be really reflective in your homework. You're going to need to know law of sines and the formula for area. So are you practicing so that you'll know those for your quiz on Wednesday?